Good afternoon, doctor and classmates. Today it is our group to present the first assignment. We will mainly talk about sampling designs and procedures from the following four aspects. Firstly, I will briefly introduce sampling. As we know, an important characteristic of inferential statistics is the process of going from the part to the whole. The part is a sample, and it is a small group that is observed. The whole is the population. It refers to a larger group about which the generalization is made. A population is defined as all members of any well-defined class of people, events, or objects. A sample is a portion of a population, so the sample refers to a few members of any well-defined class of people, events, or objects. For example, in a study, students in American high schools constitute the population of interest. You could define this population as all boys and girls attending high school in the United States. Well, the students of Washington High School in Indianapolis constitute a sample of American high school students. Statistical inference is a procedure by means of which you estimate parameters from statistics. Parameters are characteristics of populations, while statistics are the characteristics of samples. Such estimations are based on the laws of probability and are best estimates rather than absolute facts. In making any such inferences, a certain degree of error is involved. Inferential statistics can be used to test hypotheses about populations on the basis of observations of a sample drawn from the population. Now we have a clear understanding about sample. How to determine the sample size? It is a controversial issue, and opinions towards sample size vary greatly. Some experts claim that sample size can be small, while other people hold a different point of view, saying if the sample is too small, it is very hard to justify the researcher's conclusion. So, how large should a sample be? A larger sample is much better than a small sample, but the most important characteristics of the sample is not the size, but the representativeness. That is to say, size alone will not guarantee accuracy. Therefore, in sample selection, size is important, but the representativeness must remain the prime goal. For example, a random sample of 200 is better than a random sample of 100. A random sample 100 is better than a biased sample of 2.5 million. How to determine the appropriate sample size? A scientific method of determining the sample size needed is to specify a meaningful effect size. Effect size is the difference between the experimental and control groups divided by the standard deviation of the control group, or the difference between two groups divided by the estimated population standard deviation. We can resort to this formula to determine the needed sample size. Determining the number needed in a sample is really a function of how precise you want to be. That is, how large or small an effect size you want to be statistically significant, how much chance of type 1 error you are willing to live with, and how much probability of rejecting a false null hypothesis you want. These are all judgment calls, but they can all be made on a rational basis. If you want to know more about sampling error and the probability, you need to listen carefully. Other members in our group will briefly and systematically explain them for you. Cohen's 1988 book and Table 2 in Olnick's 1984 article can be considered as a standard references for determining the minimum sample size for the different statistical tests. Now let's go on to talk about the rationale of sampling. So if you want to know the rationale of the sampling, firstly, you must know the concept of sampling. So sampling means to draw a portion from a larger population, make observations on a smaller group, and finally generalize the findings to the parent population. Sampling is indispensable to the researcher. Many factors such as time, money, effort do not permit a study on all possible members of a population. It is generally not necessary to study all possible cases to understand the phenomenon. So that means if you want to understand the phenomenon, you just need to study a few cases. But you must be sure your sample is representative. A non-representative sample is termed as a bare sample. The findings on a bare sample in a research study cannot legitimately be generalized to the population from which it is taken. For example, If the population of interest is all students in a particular urban school district, but the researchers sampled only students from the district's 2 magnet schools, the sample will be biased. So here is the steps in sampling. There are 2 steps in the sampling. The first one is to identify the target population. The second one is to select the sample. But here we better notice the differences between the target population and accessible population. The target population is a large group to which the researcher wishes to generalize the results of the study, while the accessible population is the population of the subjects accessible to the researcher for joining a sample. Once we have identified the population, the next step is to select the sample. 2 major types of sampling procedures are available to researchers: probability and non-probability sampling. Probability sampling involves sample selection in which the elements are drawn by chance procedures. The main characteristic of probability sampling is that every member or element of the population has a known probability of being chosen in the sample. Non-probability sampling includes methods of selection in which elements are not chosen by chance procedures. Its success depends on the knowledge and the judgment of the researcher. Non-probability sampling is used when the application of the probability sampling is not feasible. Its advantages are convenience and economy. So the next presenter in our group will go on to explicitly and systematically explain non-probability sampling and probability sampling. Thank you.
Hi, I'm Gao Jing. Next, I will present you probability sampling. Probability sampling involves sample selection in which the elements are drawn by chance procedures. The 4 types of probability sampling most frequently used in educational research are simple random sampling, stratified sampling, cluster sampling, and systematic sampling. First, let's look at simple random sampling. In simple random sampling, all members of the population have an equal and independent chance of being included. There are 4 steps in simple random sampling. The first one, define the population. Here, in the previous case, 800 students in Washington High School is the population. Step 2, list all the members of the population. For identification purposes, we would assign a distinct identification number to each individual in the population. We use a number from 000 to 799 for this purpose. Each individual must have an identification value with the same number of digits as every other individual. Number 3, select the sample by employing a procedure where sheer chance determines which numbers on the list are drawn from the sample. There are 2 ways of doing this. The first one is called fish bowling. This one is to use a table of random numbers, typically 4 to 6 digits in length, arranged in columns and rows. This table is produced by a computer program that guarantees that all the digits from 0 to 9 have an equal chance of occurring each time. We roll a die to determine which page to use. We roll a 3, so we pull the 3rd page. Then we note the last 2 digits from the serial number on the dollar bill. They are 03, so we go to row 3. Then we take the last 2 digits from a second dollar bill, which are 22, taking us to the intersection of row 3 and column 22. The intersection of the row and column is the location of the first random number. Here, we will only look at the first 3 digits of the numbers. The first 3 digits from that intersection are 403, so the individual with number 403 is in the sample. The numbers can be vertically or horizontally in both directions. Of course, we should specify the direction we will use prior to entering the table and use it consistently. We have decided to move vertically. So the next 3 digits are 479, 243, and on down the column to the next column and continue the process until we have 50 random numbers less than 799. In this way, the number drawn from a table of random numbers can be absolutely without bias. Number 2, You most likely will have access to web-based random number generators such as Research Randomizer. If you access this website, you will find information about the Research Randomizer and a tutorial on how to use it to generate random numbers quickly. When the population consists of a number of subgroups or strata that may differ in the characteristics of being studied, it is often desirable to use a form of probability sampling called stratified sampling. You first identify the strata of interest and then randomly draw a specified number of subjects from each strata. The basis for the stratification may be geographic or may involve characteristics of the population such as income, occupation, gender, etc. You may either take equal numbers from each stratum or select in proportion to the size of the stratum in the population, which is known as proportional stratified sampling, in which each stratum is represented in the sample in exact proportion to its frequency in the total population. For example, if 10% of the voting population are college students, then 10% of the sample of voters to be polled will be taken from this stratum. When the population to be sampled is not homogeneous but consists of several subgroups, stratified sampling may give a more representative sample than simple random sampling. As mentioned previously, it is very difficult to list all the members of a target population and select the sample from among them. The population of UPM international students, for example, is so large that you cannot list all its members for the purpose of drawing a sample. So, it would be more convenient to study subjects in naturally occurring groups or clusters. A researcher might choose a number of schools randomly from a list of schools and then include all the students in those schools in the sample. This kind of probability sampling is referred to as cluster sampling. Because the unit chosen is not an individual but rather a group of individuals who are naturally together, it is essential that the clusters actually included in your study be chosen at random from a population of clusters. Once a cluster is selected, all the members of the cluster must be included in sample. Still, another form of probability sampling is called systematic sampling. This procedure involves drawing a sample by taking every case from a list of the population. First, you decide how many subjects you want in the sample. Here we say 50. And because you know the total number of the members in the population, we take it 500. You simply divide 500 by 50 and determine the sampling interval k equals 10 here to apply to the list. Select the first member randomly from the first k members of the list. Here we take 3, and then select every k, here just 10, we add 10, of the population for the sample. Thus, 13th person falls in the sample as does in 23rd, and so on, and would continue adding the constant sampling interval until you reach the end of the list. In systematic sampling, the various choices are not independent. Once the first case is chosen, all subsequent cases to be included in the sample are automatically determined. These are the 4 types of probability sampling. Be noticed that the various types of probability samplings that have been discussed are not mutually exclusive. Various combinations may be used.
Hi, dear doctor and my classmate. I will present content of non-probability sampling as concept of sampling error. So I will just start from the non-probability sampling. Because enumeration of the population elements is difficult or impossible, and the random selection of the sample is not permitted for the researchers. So under such circumstances, we have to use the non-probability sampling. Non-probability sampling just involves the non-random procedures for selecting the number of the sample. So there's no assurance that every element would be included. However, the advantages of non-probability sampling are convenient and economy. First types of non-probability sampling, there are three. The first one, convenient sampling. Second, purposive sampling. And last, quota sampling. We'll go through them one by one. The first, convenient sampling. Convenient sampling is regarded as the weakest sampling procedures because it just uses available cases for study. For example, use the students your own classroom as a sample. It's very convenient, yes. Because there's no way to estimate the error, so it can be considered as the disadvantages of the convenient sampling. And well, on the other hand, sometimes it's just all available to the researcher. So under this circumstance, it is better than any other sampling methods. But nevertheless, when employing this sampling method, please be extremely cautious in interpreting the findings, and you have to know that findings could not be generalized. We'll move to the purposive sampling. Purposive sampling just equals to the judgment sampling because sampling elements judged to be typical or representative are chosen for population. The assumption is that errors of the judgment in selection will counterbalance one another. So it's used for forecasting national elections. Well, for the advantages and disadvantages, first look at disadvantage. Because unit could not be typical of population permanently, so the result may be misleading. And well, for advantage, because its locus is convenient and it's just useful in attitude and opinion survey. At last, please be aware of the limitation and to use the method with extremely caution. Well, the quota sampling. Quota sampling just involves selecting typical cases from the diverse strata of the population. And the quota is based on known characteristics of the population to which you wish to generalize. So in this way, element adjoined so that resulting sample is a miniature approximation of the population. And because individuals chosen from each stratum may be not representative of the given stratum, and the selection of the elements is likely to be based on the accessibility and convenience. So the disadvantage of the quota sampling is that the procedures automatically result in a systematic bias in a sample because certain elements are going to be misrepresented. Furthermore, there is no basis for calculations error involves the quota sampling. And as for the advantage, because selection of the element is convenient and accessible, so it's widely used in many projects. Researchers believe the speed of data collection outweighs this advantage, and years of experience with quota sample have made it possible to identify some pitfalls and to take steps to avoid them. Well, first concept sampling error. We know that when we make reference from the sample to the population, amount of the error will just occur because even random sample can be expected to vary from one another, and the researcher observe only a sample and not the entire population. Well, we can see that sampling error is a difference between the population parameter and the sample statistic. Here is a formula. We use U to represent mean of the entire population, X the random sample from the population. So E just equals to X minus U. That is just means the sampling error. Well, as law of nature sampling error, because the samples from the same population just vary from one another. So my question for you is that, is using sample to make inferences about population better than just guessing? Well, the answer is definitely yes, because sampling error behave in a lawful and predictable manner, and the laws concerning sampling error have been derived from the deductive logic and have been confirmed through this experience. Also, researchers can predict nature and extend the error in the single sample. They can predict nature and extend a sampling error in general. Well, sampling error of the mean. Here we have some laws. The first one, the expected mean of the sampling error is 0. Given an infinite number of random samples drawn from the single population, we can see that the positive errors is equal to the negative errors. So the mean of the sampling error will be 0. Well, now sample mean, we can see that sampling mean is unbiased and the reasonable estimate of the population mean. Well, law 2, sampling error is an inverse function of the sampling size. Okay, as the sampling size increases, the sampling error will just decrease. Okay, we can say the relationship between them is mathematical. Well, first, law 3, sampling error is a direct function of the standard deviation of the population. The more spread or variation there is amongst members of the population, the more spread there will be in sample means. Well, last of 4, sampling error are distributed in a normal or near normal manner around the expected mean of the 0. Sample mean nearest population mean will occur more frequently than sample mean far from the population mean. Both theory and experience have shown that mean of the random sample are distributed in a normal or near normal manner around the population mean. Well, for standard error of the mean, since the extent sampling error could be predicted, so we just use sampling means to predict the population means. To do this, we have to know the magnitude of the sampling error. Well, the useful tool for this is sampling error of the mean, and it just manifests itself in variability of the sampling means. Well, we know there are 2 things, just the effect size of sampling error. The first one, that is just the size of sample, and the other, that's the standard deviation of the population. If both of them are known, we can predict the standard deviation of the population error. It just equals to the standard error of the mean. Well, the formula goes like this. The standard error mean is equal to standard deviation of the population divided by the square root of number in each sample. Here is just the formula and the meaning of each element. Okay, so we just go on. Because standard deviation is index of the degree of the spread amongst individuals in population, and standard error of the mean is index of the spread expected amongst means of the samples drawn randomly from the population. So we can say the interpretation of the standard deviation is similar to the standard error of the mean. So the mean of the random sample have approximately normal distribution. The novel curve model is used to make inferences concerning population means. Okay, given that expected mean of the sample means equal to population mean, standard deviation of this means equal to standard error of mean, as means of the random samples are distributed normally, we can conclude that we can compute a z-score for a sample mean and refers to z to the normal curve table to approximate the probability of the sample mean. Well, unless the formula, if z is divided by subtracting population mean from the sample mean and then divide this difference by standard error of the mean, we have this formula at last. So it's all I want to present. Thank you so much.